Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing one of these. Now I'm calling this SpiroMoGraph, and when you were a young child you may have had a Spirograph toy, and many children do. I know I had one and they're a lot of fun for producing geometric patterns. And that's what we're going to be doing here. Now this is all controlled by Expresso. There's no Python involved in any of this, so it's an Expresso project, and we're just going to be simply using a tracer from MoGraph, hence why I'm calling it SpiroMoGraph. But anyway, that's what we're about in this tutorial, so without further ado, let's see if we can make this happen. The first thing I'm going to do is create 4 circles. So I'll create 1, 2, 3 and 4, just command drag to create the extra circles there. This first circle I'm going to call inner, the second outer, world and wheel, and you'll see why I'm using those conventions a little bit later. The inner I'm going to make 150 radius, the outer 250, and the world I'm going to leave at 200, and the wheel I'm going to make 50. So they're going to be our starting points for our circles. The next thing I'm going to do is create 2 nulls. The first I'll call carrier, and the second pen. Now the carrier I'm going to bring down to here, and I'm going to drop the wheel into it, and I'm going to drop the pen into the wheel. And that's fine because everything is set up the way I need it to be. That's great. So the next thing to do is to give the carrier an animation tag, and it will be an align to spline. And what we're going to do here, I mean, initially we'll put the inner in there, and that immediately moves our wheel to the inner, which is now the inner path, and the outer of course is going to be the outer path. Now the world is what the wheel is going to roll around, and that's why I've called it the world. And you can see that the wheel is the correct diameter to be touching the world, and that's what we need. So that's exactly why I've set this up the way I have. It's a similar story if we drag the outer into the path field there. So this is what we've got to maintain regardless of how big the radius of the wheel is. So if we make it smaller, we're going to want the outer to adjust and the inner to adjust accordingly, so that when we swap them over, we're still going to have the world and the wheel touching each other. That's going to be the next port of call. In order to do that, we're going to need another null. We'll call it Expresso, and we'll give it the Expresso tag. Come down to programming, Expresso. The window's open. We'll make it a little bit smaller initially, and we're ready to start work. Right then, how are we going to go about doing this? Well, the first thing we need to do is drag in the world and the wheel, and we'll give these at the outputs, come down to object properties and give them radius ports. So they're ready to go. We then need math nodes. So we'll get one of these, just get a math. And the first one can be an add. I'll command drag to copy and make this one a subtract in the function. And then all we've got to do is plumb them in. So we can add these two, and we can also subtract basically the wheel from the world. That's what we're doing. So that's the important way to do it. Subtract the wheel from the world when you do the subtraction. The add doesn't really matter which way round they are, but it does for the subtraction. Okay, and then the next thing to do is bring in the 2 paths. So we've got the inner and the outer. The outer path actually needs to be plumbed into the add, and the inner the subtract. So we'll do that now. Go into our object properties again and select radius, and the same with the inner. and then we can just have a quick check to see if we've done this correctly. So let's just close the window a minute. And now what we'll do is select the wheel and we'll alter the radius. So let's just play around with this, and we can see that that's working fine, doing exactly what we said it should do. Let's just go into here and swap the outer with the inner. Select the wheel again and play around with the radius, and we can double check, and it's all working perfectly, exactly as I said it needed to. So that's lovely, a nice simple formula there. Just literally add the two and then subtract the radius of the wheel from the world. That's the golden rule. Don't do it the other way around. Okay, and then the inner is the subtract, the outer the add. And that gets the first little piece of this complete. Moving on from here then, we've got to think about making the wheel revolve around the world. Let's just move this out of the way. Now at the moment, if we go into our position here, we can see that the wheel is indeed going to move around the path, but at the moment it isn't rotating. We've got to make it rotate as it moves. And when it's moving along the inner path, it must rotate clockwise. When it's on the outer path, anti-clockwise. So we've got to take these two things into consideration. But first, what we need to do is work out the actual speed of rotation, because obviously we want it to rotate the correct amount of times when it's done one revolution of the path. So how are we going to do that? Well, we've done it before, haven't we? Because when we did the caterpillar tracks, if you've done the caterpillar tracks tutorial, we actually, what we did, we worked out the circumferential length of the wheel, and then we worked out the length of the track spline, and we divided the track spline by the circumferential length of the wheel, and we've got to do the same here. So we need to find the circumferential length of the world, and we need to divide the wheel into that circumferential length. The circumferential length of the wheel needs to be divided into the circumferential length of the world. So how are we going to go about doing that? Well, normally we do it using the calculator, but on this occasion we actually need that formula within the Expresso expression, because obviously if we're going to be changing the radius of the wheel, then every time we do that, it's pretty obvious, I think, that the circumferential length of the wheel itself is going to be changing. But of course the world, well, that doesn't change. It always stays the same. So we need to be able to constantly get a hold of this circumferential length within the Expresso expression. So how are we going to do that? Well, it's quite simple. We can command drag to copy this here, and in the function make it a multiply. In fact, we'll get two of those, place them down here, and we'll plumb the world into the top one and the wheel into the bottom one. Now we've got radius here. Now in order to get the diameter of the wheel, which is what we need first really, we know that the formula actually for finding the circumferential length is going to be 2 times the radius times pi. That being the case, we can therefore multiply the radii of these two by 2. So if I select both of them, and in the input 2 I just select, or just type in 2. So we've got our first part of our formula. We then need to copy these again, and in the second ones we've got to put pi in the input 2. So we can say 3.142, that's accurate enough for us, and then plumb these two into the top inputs, into our input number 1s on those. We can then divide the world by the wheel, so that will give us the next part of our formula. Let's get a hold of one of these again, so command drag to copy, plumb these two in here, and set the function to divide. And we're almost there now with the formula. And then the next part of it again is another multiply. And we'll multiply this by 360 to give us the number of degrees of rotation. So let's do 360 in our input 2 and plumb our input from the divide, or our output from the divide, into the input 1 of the multiply. And that's our formula complete. So that's constantly going to tell us what we need in here. So no matter what we do with the wheel, no matter how much we change the radius, it will all work out in here, and that's fine. Okay, that's brilliant. So that's the next little part of this complete. The next port of call for us is to just shut down this window for now, and then we'll think about adding some user data to our Expresso tag. Right, so let's just add some user data. Just remove that for a minute. Add group, and we'll call this group controls. And within there, we'll add some more groups. So we'll add one. Don't want that grouped, but we'll just put that there, add another group, open that and put that there. Right, so controls will move away from our user data default. Our first group I'm going to call path. The second, wheel radius. Just give that a capital, wheel radius. And the third, pen position X. Now in the path, we need to add some data. The data type is going to be integer. The interface will need to be radio buttons. And we need in our cyclic option to say, or cycle option to say value semicolon string. So 0 semicolon inner for our first option and 1 semicolon outer for our second. We can then go into our details tab here, and in our columns we can say 2 in there, and if we click example we can see that this is what's going to appear on the screen, and that's exactly what I want. So coming back to properties, we can say in here just simply a minus sign followed by a greater than sign. That's what I'm going to use for the name. In the wheel radius, if we add some more data, we've got that there. This is going to be a float data type. The interface will be a float slider, a real unit, and for the wheel radius I'm going to say a step of 5 because I found that to be the most useful. You can change this if you wish, but that's what I'm going to use here. And in the limit, min and max, I'm going to say minus, no, I'm not going to say minus, I'm going to say 10 to 180. And I'm going to clamp those values. We'll start with the default at 50. So that's all set up. And then finally, we just need to do that again for the name. We can then select the pen position, add data, and we can do the same thing again in there. It will be a float, it will be a float slider, a real value, and a step value of 0.01. And on this occasion we'll say minus 200 to 200 for our limit, min and max, and once again we'll clamp the values. We'll set the default to, let's say 100. Split the difference for the sake of arguments, or in fact let's say 0. We'll say 0, that might be easier. Okay, great, that's fine. So I think we can hit OK and we should have what we want. Let's have a look. So yes, controls are there. Yeah, it's all okay. That completes our user data thus far. The next port of call for us then is to go back into our Expresso expression here and begin working on the final steps to getting this all working. The first thing we need to do is bring in the Expresso null, and in our controls here just bring all of these in. So we'll bring in path, we'll bring in pen position X, and we'll bring in wheel radius and open it up. Moving on from here, we'll grab a compare node, place this over here. Now our path is what we need to come out of there because we need to compare this to equal to 1. So we'll just say equal to 1 in input 2. And for now we don't need to concern ourselves with this anymore. We'll be coming back to it a bit later. We'll just move this out of the way because the next thing we've got to bring in is the pen. because we need to simply say we've got to drag, this is our pen position, X, so we can drag this out here, coordinates, transform, position, position X. That's what needs to be placed in there. So that's ready to go. Let's just make that a little clearer. And then moving on from here, we can think about grabbing a condition. So we'll get a hold of one of those, bring it in, just place it here. And then the path, once again, here, this will be the selector for that. So we'll plumb that in there. And then we've got our paths that we need to bring in. So we'll bring in the inner and outer, drop these over here. And these can both be given object output ports. And then simply plumbed into here. In fact, we need to change the conditions data type, and we need to make this spline. And then we can plumb these in. Oh, can we? I hope we can. Perhaps we can't. Let's have a little look and see what we've got. Oh, sorry, that is, it's not spline, it's link. I beg your pardon, it's link. And then we can plumb the two of those in. There we go, that's right. Okay, that's brilliant. So those two are done now. So that will allow our integer here, which is technically a bool, it's a 0 or a 1 that's going to come out of here. So we're going to switch between the inner and outer paths depending on what we're doing with our radio buttons in the user data here. So we'll select the inner, which will be 0, and the outer, which will be 1, and that will do that for us in here. And to finish this off, we can bring in the align to spline tag, and in our tag properties, select spline path, and then simply plumb the output of the condition into the input. And that sets that little part of it up. Now, if we just close this down, we should go into the Expresso and we should be able to use our radio buttons, and we can. So that's great. We can switch between the two, and that's working. Fantastic. So let's just open the Expresso again and we can move on to the next part. At the output stage of the align to spline, we'll add a position port. And then we can think about what we're going to do here. Now, the next thing we need to do actually is to bring in this formula into this part of the expression. So we've got to add the necessary nodes to enable us to do that. The first thing then to get hold of is two range mappers. So we'll get a hold of those. Bring the first one in, and we need to add an output upper port into the range mapper, and then we can command drag to copy. So we've got two of those. Moving on from here, we need a degree node. So calculate degree, because this needs to plumb, or we need to plumb the output of the multiply. So we need the output of our formula. We need to plumb into there, and we need to say degree to radians, because we're working with degrees at the moment and we need to work with radians. If we just move these along a bit, I need a negate. So if we come down to calculate, bring one of those in, and we'll put this just here. And the degree node can be plumbed into there. And we can plumb the output into the output upper of our bottom range mapper there, and then the degree output here can be plumbed into here. So that's that little part of it set up. We can then take the position out here and plumb this into the inputs of both of our range mappers, and that gets that piece of it sorted out. Now, earlier I said that we would use this compare. We'd come back to that a little bit later, and now's the time when we need to do that. We need to get another condition, so we'll bring one of those in. We can leave it set up as is. The function can be real because we're going to be using real values as the data type, I should say, not the function. The data type will be real. So that's all good for us. And then we can use the compare here to switch between our range mappers. That's what we're going to be doing. So we can plumb our top range mapper into here and our bottom range mapper into here. So we're literally using our align to splines here, and the reason we've got the negate is because if we're using the outer spline, we've got to rotate in anti-clockwise, so that's where the negate comes in. And of course, if we're using the inner, then we're going to be rotating clockwise, and we're using the upper range mapper for that, and that's where the condition is being used to switch between them as need be. That's fine. And then the last step is to bring in the wheel, give it a radius port, and we also need a rotation B port. So transform, rotation, rotation B. We'll just swap those over. Okay, so the rotation B, that's going to be the output of our condition, and our radius is going to be controlled by our user data. Now let's just bring this over a little bit further so that we can see what we're doing. It's quite a large expression actually. So this output port here that we haven't used yet, that's going to be the port that controls the radius. Okay, fantastic. So that's our expression set up, and it should be working the way we want it to. It's not quite finished because I'm going to come back and do a little bit more to it later, but that's a sort of little bonus thing that I'm going to add. But that's essentially the expression that should give us what we want. So if we select the wheel and we select our align to spline, we should be able to move this and it should rotate correctly, and you can see that it does. So it's correct, it's rotating in the correct direction around the outer. And if we go into our Expresso and select the inner, we instantly select that, and we can then go back into here, and then we'll see what goes on here. Let's just select that wheel again, select that again, and let's just see what we're doing. And you can see here it's rotating correctly, and it's going to be working perfectly well. Okay, that's fine. So that's all good. We're okay there. Brilliant. So we can move on from here and start thinking about bringing in a tracer object which we can use for our pen. If we come into our drop down here, we can select a tracer, drop this down at the bottom of the pile. Now what I'm going to do, I'm also going to select or bring in a circle and make it 0.5 in the radius, bring that down here, and then I'm going to bring in a sweep and drop these both into there, because obviously I want my tracer to draw onto the screen rather than just letting it draw a spline. I'm going to let it draw a swept object onto the screen. Okay, so in the tracer, what I need, I don't need the wheel in the tracer. What I do need is the pen. I'll drop that into the trace link. Everything here I'm going to leave alone. The global, I'm going to leave none. Now, when it comes to the spline type, I'm going to leave that as linear, and the intermediate points as none. Whatever you do, don't change these. It will cause more problems than it solves. So let's go into our Expresso here. Now our pen position is currently 0. So if we select the pen, we can see that it's at the center of the circle. Well, that's not going to give us anything. So what we'll do is grab a hold of our Expresso again, and with this pen position, we'll just move it so that it's just anywhere away from the center at the moment. In fact, what we'll do, let's give it a value of 30. And then what we need to do in order to make this work is actually animate the position of our align to spline. I'm going to give myself a few more frames. I'll say 450. I'll record position 0 at frame 0, and what I'll do is go to the end of our animation and set this to 100%, and then record again. If we go back, let's just see if we get anything at all here, and you can see that we're drawing something onto the screen. And what are we going to get? Right, at the moment, we're getting something that's a little bit odd. It's not going to line up, and that's because we've not set this up correctly in order to do that. Another thing I'm going to do is just go into my dope sheet here, or the F, it's not the dope sheet actually, it's the F-curve timeline. And we've got this set up in the wrong way. We want it to be linear. So we'll just change that. We don't need the ease out, ease in curve because we don't want it slowing up, speeding down. There's no reason for that. So we'll leave that as it is. That's looking okay. What we'll do in the user data here, if we set this to 50, we'll leave it on the inner spline. And there's a little bit of a lag problem there, and I know what's causing that, but I'm not going to correct it. What you need to do, it just doesn't matter. But what you need to do, we just move this over a little bit. When you've got the X manager here, in the X group, probably need to do a little bit of work in here just to put things in a different order. That's probably what's causing that. The interesting thing is that when I built the original scene, I didn't get this problem. And I think that's because I approached the Expresso expression in a slightly different way. I built it in a different order. And I think that's probably what's causing this lag problem. But as I say, I'm not going to worry about it because it won't affect the performance of what we're doing here in any way, shape or form. Okay, let's give this a go because we set our Expresso up to 50/30. Let's see what we get this time. I'm going to click on there a number of times because I don't want a dodgy glitch here. So let's see what we get. Okay, all looking good. And we should actually get a 5-pointed star. And that's what I think we're going to get. And indeed we do. What I'll do as well in my animate menu here, in my play mode, I'm going to set this to simple because we don't want to repeat. So that's fine. Anyway, that's got that set up very nicely. Another thing I'll do in the sweep is come into the basic here and set this to automatic, and I don't know, we'll make this say a green sort of color. That'll do nicely. It'll show up better then. Let's run the animation now and see what we get. Yeah, and we're getting quite a nice green 5-pointed star. Great, so it's all working really nicely. If we just move that round to there, we'll get a better view of it. That's looking nice. So yes, you can see that this is working as it should. And if we were to switch to our outer here, just return to the start and let's see what we get this time. So we get something completely different. And there you have it. And that's looking quite good. Now, if we were to set this to 100 in the wheel radius and 100 with the pen, we'll just hit H to bring everything center screen. We should now be able to generate a cardioid. So if we run this, what I'll do is just stop that because we've got this straight line here. Don't want that in. Just hit return to 0 a number of times and it'll get rid of that. So let's just run this now. And we can see that it's generating a cardioid. So there are many different shapes that you can get by using this. It's quite a versatile setup. And the key to it, it's a combination of setting your wheel radius, setting your pen position, and also coming down into here. If we just select this keyframe, we can come in here and we can change this keyframe value. So there are a number of different sweet spots that I've found while using this. And let's just see if we can set another one of those up. So if we set, I'm just going to get to my notes here, have a quick look. Let's have a look. So if we say, let's just do the Expresso first, 75 here, and we'll leave that at 100 for the position X. And then the align to spline, we need to set the value of this keyframe to 300. And we'll return to 0, hit the button a number of times and then hit play. And we're currently on the outer edge and I want to be, or rather on the outer path, and I'd like to be on the inner. Okay, let's see what we get now. and we're producing a flower. And very nice. And that would work, I suppose, as a logo, possibly for a flower shop, maybe a florist's, you know, Flo's Florists or something. You know, that would be quite good for that. I mean, again, we can get rid of this straight line. Just click, click, click a number of times on this and it will get rid of it. I wish it would reset properly, but just by hitting the thing back to 0. But I think it's because of the way the tracer works, I think. But yeah, I mean, that would be quite a nice little logo thing to draw on for a florist shop or something like that, maybe. So that's, you know, just one idea that you can have. Now, to finish this off completely, the thing I'm going to also add is a 3D mode, because at the moment it's flat basically. So I mean, it is 3D, of course, because we do have the sweep around a circle, but it's not as three-dimensional as it perhaps could be. So what we can do is add a little bit more to our Expresso expression here, but the first thing we need to do before we get there is to go into our user data on the Expresso null. So if we say add user data, we've got some data already. We'll add another group, drop this into our controls, and we'll call this mode. We'll drop the data into mode, and this will be another integer, and again it will be radio buttons. This time we'll say 0 semicolon 2D and 1 semicolon 3D. We'll go into our details, add 2 columns, and now we're getting what we want, so that's all good. And we can also once again type this in the name field. Okay, so we're all set up and we're ready to go. So we'll hit OK, and straight away our mode comes up in there and it's ready for us to use. So we can open up the Expresso expression, and in our controls we can add mode. Just make that a little bigger. Okay, that's fine. And then over here we can think about what we're going to do here to make this work. So with our wheel here, what I'm going to do is add rotation H. So come down to coordinates, transform, rotation, rotation H. I'm going to add that in at the bottom. Move this over a little bit and then create another condition. So I'll just copy this one. And that's set up as real, so that's perfectly good for us. And just move this down a little bit, I think, just to make things a little bit tidier. And then what we can do is basically, if we're in 3D mode, we want to use what's coming out of this condition here. So whichever of these two range mappers is being used, we want this to be plumbed into the rotation H as well as the rotation B. So we'll plumb that in there. And other than that, we can just leave it at 0. So that's fine. We can leave input 2 as 0. And then if we just make the window a little bit bigger so that we can see what we're doing, we can then get the output of here and use that to switch this condition between 0 and whatever's coming out of here. So if we're in 2D mode, we're going to get 0. If we're in 3D mode, we're getting what's coming out of here plumbed into rotation H. And that will finish it off and make it produce a 3D pattern. So let's see what we get. Let's just return to 0. We'll leave this set up as it is. We'll just see exactly what we get. So we'll hit 3D mode this time and run the animation. Straight away you can see we're getting something completely different. Doesn't even begin to resemble a flower. But there you go. That's what you get if you change it. You get a much, much more abstract pattern. Completely abstract if we just render that. Yeah, it's completely different. But nonetheless, still very usable. You know, I mean, that could be used in a logo type for, well, I don't know what. It's for you to decide, I suppose. But it goes to show you how versatile this setup can be. And if we go into the outer and we'll just return to 0 and have a go and see what we get this time. And again, you can see we're getting something completely different completely abstract. But an interesting, very interesting pattern. And there you go, there it is. Another totally unique outcome. So yeah, it's quite a versatile setup that we've got there. And, as I say, there are a number of different sweet spots within it. It's just a combination of the wheel radius, the pen position, and then playing around with the final percentage value here. So you can play around with this to your heart's content and see what you can come up with. But yeah, as I say, there are a number of different sweet spots, and I've just put a card on the screen with some in there that you can have a go at yourself. They're mainly, well, these are all 2D ones actually, but please play around with the 3D and see what it actually does to them. But yeah, I mean, that's basically the end of the tutorial. That's how you go about creating a SpiroMoGraph. So as per usual, I'm just going to hit H in here so that we can see the whole expression. As per usual, I hope you've enjoyed this one and that it's been of use to you and you've got something out of it. And I'm hoping that you can have a good play around with this, and maybe you can come up with something a little bit different for it and see what you can do. Maybe you can enhance it in some other way. I don't know. But anyway, that really does bring this tutorial to an end. Before I go, though, we'll just do a little bit of a quick recap, shall we? I mean, we've got 3 separate sections here, effectively. Starting at the top in this first little section here, we're using the radius of our wheel to automatically adjust and control the radii of our paths. We've then created the formula so that we can constantly divide our wheel radius into our world radius and make the wheel rotate the correct number of times as it travels around the world. That's what we're doing here. And then from there, we're just bringing in the various elements, and we're controlling our pen position from a piece of user data here. So if we're adjusting that pen position, we can, if we select the pen and we select our Expresso, I need to select both of them at the same time really to see what's going on there. I'll tell you what we'll do to see that. If we just go into our Object tab, we'll change the dot to a circle. Or rather, let's do it as a diamond. That will make it easier to see. And we can now see that we've got a diamond there, so we can see where the pen is. And if we just come into here and start playing around with the position, you can now see where it is and what it's doing. So it's probably quite a good idea to set that up in order to give yourself a clear indicator. But anyway, that's the control of our pen. And then with the compare here, we're simply saying we either want to move, or rather rotate, our wheel clockwise or anti-clockwise. So we're switching between what these 2 range mappers are doing. And obviously we've got the negate in front of this one to make our range mapper here move our wheel in an anti-clockwise direction. So that's quite simple. And then finally down here, we're switching between the 2 paths. We've got our inner and our outer, and we've got our radio button here which switches between the 2 paths. It's controlling obviously this as well as this. And then we're also then controlling the radius of the wheel by using our user data down here. That's using that to switch that in steps of 5 as I put in there. And then finally we've got another condition whereby we can switch between the 2 modes, the 2D and the 3D mode. And the 3D mode simply allows us to rotate the pen around, or rather the wheel I should say, around its rotation H as well as its rotation B. So it is a simple setup really. It's just done in various different steps, and that's all you need to do in order to make this work. It works pretty well, and you can come up with some quite interesting stuff I think using this. But anyway, that just about wraps this one up. So as always, I hope you've enjoyed this tutorial and that you've got some good stuff from it and that you can use it in your own projects. And if you have enjoyed the video, then please give it a thumbs up. And if you haven't already, then please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please share this video, because all this good stuff helps keep the channel moving in the right direction. But anyway, that brings the curtain down on this one for now, so I'll see you very soon on the next tutorial.